Hello, tubers! Once again, that's a tube of toothpaste. Okay, we're back. Sam Moore here again, and we're going to continue our exploration of the electronics in your handy-dandy electric guitar. We're going to do a lot of fun stuff today, but again, we're going to keep it quick and easy, and there's not going to be a whole lot of math involved, and we're going to have some fun at it. Welcome back. What are we going to talk about today? We're going to talk about atomic particles. Why? Well, because we're talking about electricity, and basically electricity is related to atomic particles and movement of atomic particles. And it'd be nice to know what we're talking about. We'll talk about electric current. What is electric current? Just exactly what does it consist of? We'll talk about voltage. These are terms that you've used many times. You've heard used in your many times, but chances are you probably didn't know exactly what they meant or what you were talking about. We'll talk about resistance a little bit. What is resistance? You know, I think everybody has a bit of a feel for it, but nobody knows exactly what they mean. Let's start with atomic particles. Let me reach back here and get my handy dandy piece of paper. I have to give actually Encyclopedia Britannica credit for this for this diagram. They're good people. Okay, this is a so-called Bohr model of an atom. Now Niels Bohr was an old scientist, lived about 1 million years ago. No, lived long ago, and he came up with one of the first models of the atom, of exactly what is inside an atom. Pretty smart dude. You'll note these particles with the little pluses on them. Those are called protons. Think of them as basketballs with a positive charge. Those are, in fact, that's a good color. They're kind of orange like a basketball, or in this picture anyway. They're kind of orange like a basketball. So think of those as basketballs, and each of them has a charge of +1. These little green goobers are neutrons. They don't have any charge. They're about the same size as a proton, but they have no electrical charge whatsoever. These little boogers out here are what we're interested in. These are the electrons. Okay, now it turns out that the number of protons determines what material we have. The most common electrical material that we use is copper. Copper has, let's have a drum roll here. Boogity, 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 boogity. Here's copper on the so-called periodic table of elements. Copper has 29. I just love how everything shows up backwards when you try to look at print on this thing. It has 29 protons. Okay, so that's what determines its copper. Now then, why are we talking about all of this crap? Good question, fair question. One that I probably would have asked, back 1 million years ago. Basically, we're talking about all of this crap because an electric current is a flow or movement of the electrons. See? These little boogers right here actually getting ripped off the atoms and moved around. Yep, moved around. Back about 1 million years ago, no, a little over 200 years ago, there was this cat, you've probably heard of him, named Ben Franklin. Ben Franklin, very smart man. Probably as smart as me. Probably, maybe, okay. Ben Franklin did some experiments with electricity. Yep, he was more than just a statesman, and he was a really interesting guy. You really should read up a little bit on Ben Franklin. But he was more than just a statesman. He was actually a scientist and did all kinds of research in all kinds of various and sundry subjects. One of the things Ben Franklin did was name the charges. What? Yeah. Going back as far as Greece, there are writings, that talk about electros and electrical phenomena, where they would take a rubber rod and rub it with a piece of cat fur, or they'd take a silk rod and rub it with, a glass rod and rub it with a piece of silk, and say, oh, this will attract little pieces of hair and pieces of paper, and it shows all of this. Well, Ben Franklin is the one that decided or discovered that there were two different charges, that there was a plus charge or a positive charge, and he named it. Okay, that's a positive charge. And there's also a negative charge, and he named it as a negative charge. So, pretty smart dude, Even to this day, we still use his names, positive and negative, for the two different types of electrical charge. I'll probably get this backwards, but I believe he said that if you rub a rubber rod with a piece of cat fur, I don't know where he got cat fur, I ain't going there, with a piece of cat fur, that it gets a positive charge. Okay, but even today in electrical engineering, and when they talk about electronics, they talk about about the flow of current being from positive to negative. Even though we know that it's really a flow of electrons from negative to positive, we all talk about it, or all the engineers talk about it as being from positive to negative, because that's what Ben Franklin said happened. Ben probably deserves that. He probably deserves that much of an honor. Where did I get to? Oh, yeah. Okay. Now, an electron has a charge, very, very small charge. Let's talk about current. Current is a flow of electrons, a movement of electrons. So you got one electron and it hops around, and it goes down through this conductor, through this wire, from here to here to here to here to here, and does all kinds of wonderful stuff to us. No, it takes more than one electron. It takes a lot of electrons. There is a unit, called a Coulomb, which is just a number, It's a number of electrons. It's the unit of electrical charge, Coulomb. How big is is a Coulomb? I had to look this up, because it's not something that you're ever going to use again, but it's just kind of interesting. It's 6.25 times 10 to the 18th electrons. That's 6.25 or 625 followed by 16 zeros. That's a big number, That's over a million times a million. A million times a million is 10 to the 12th. So a million times a million times a million is 10 to the 18th. Whoo! That's a lot of electrons. If you put them rascals in a bucket, you wouldn't even see them, but because they're so small. But the units of electrical current are amps or amperes, usually shortened to amp. And an amp is 1 Coulomb per second. But basically, an amp is just a whole mess of electrons flowing past one point in 1 second. I was going to go into all kinds of calculations and try to figure out exactly how many 6.25 times 10 to the 18th is. And so I said, well, let's compare it to BBs. If we had 6.25 times 10 to the 18th BBs, and I went and I looked up, how much does a BB weigh? It's 0.345 grams, and then multiplied that by 6.25 times 10 to the 18th, and I still got some huge number of grams. So I said, well, let's convert it to a unit that people are more used to. Let's convert that to pounds. So let's divide that by 456. I got that number off of a box of Ritz crackers. If you pick up a box of Ritz crackers, it tells you 1 pound, and then it says 456 grams. Oh, who'd have thought a box of Ritz crackers would be that useful? Anyway, so I divided that number by 456, and I still got some number that was bigger than a million times a million times a million pounds of BBs. So I said, I wonder how many tons that is. So I divided by 2,000, to convert it to tons. That's English tons, you know. And I still got some number that was 10 to the 16th. So, man, that's a lot of electrons flowing through past a point to make it 1 Coulomb. Okay, so now I'm sure that you're all experts on Newton's laws, and you've probably heard Newton's law that F equals ma. Force equals mass times acceleration. So you have to have something to make all of these electrons move. They're not going to move just on their own. They're not going to just jump up and decide to go from here to here and there to there and do all this wonderful stuff for us. We have to make them move. We have to force them to move. Voltage. Ta-da! Back in the day when I was younger and I still had dark hair, they used to talk about electromotive force. Haven't heard that term in years and years and years, but I kind of like it because voltage is the force that makes those electrons move. Okay. Now, it's not really a force. When you get into start studying electromagnetic fields and all of that fun stuff, you feel that voltage is closer to a potential energy. If you take a pound weight and lift it up 1 foot, it's said to have 1 foot-pound of potential energy. In other words, if you turn loose of it, it will fall and it'll do 1 foot-pound's worth of work in falling. Well, voltage is kind of the same way. They say if you take a charge and it's sitting here in space and you take another charge and you move it together, and we've all heard like charges repel and unlike charges attract, but if you and you move it together, there's actually a force being exerted on this charge by the electric field of this one. So that force times that distance is the voltage. It's actually the change in voltage caused by moving it from here to here, but it's actually a force times a distance. So it's not really a force, it's a force times a distance, but for our purposes, we'll think of it as the force that actually moves the charge. Okay, let's talk about resistance. What is resistance? Resistance is electrical friction. Anything you try to do, there's actually a physical law, in physics called Lenz's law, that says no matter what you try to do, there's something that tries to prevent you from doing it. I like that. Resistance is the force in nature that tries to prevent you from moving those charges. It's I'm not going to say it's working against you, but it's working against you. A lot of times it's good, sometimes it's bad, but sometimes it's good. It's just the opposition to current flow. Now let's talk about what do we need to remember from today? Okay, atomic particles? Probably not. You might want to remember there are electrons out there, and there are little negative charges that surround a nucleus. An amp is the unit of current. It's the flow of electrons. Probably want to remember that. Voltage is the force that moves the current. You want to remember that. That's important. And resistance is electrical friction. You probably want to remember that. Now, next time we start one of these things, we'll continue with resistance a little bit. We'll talk about Ohm's law a little bit. We may even make a couple little resistors. And then we'll talk about pots. This is the first component in your guitar that we're going to discuss is potentiometers. Until then, keep on picking, and adios.